Okay, guys, well, thank you for everybody coming out. I think we should take this opportunity to actually talk about how things are moving along in a project where we're already using the Stowe and Skyrise product, and at the same time get into the details of what our product is. And always looking to be at a leading edge, which is why we chose to use this system in the first place. Is we want to be leading edge developers, bringing products that bring our homes into the next generation, our products into the next generation, and bringing the best possible end result to our buyers. So that being said, I think that we can start going back into the history of Stowe and what it is, and then how you guys blended Stowe with Skyrise and how we're applying it today. So,
Yeah, I'll start with a bit of the history of Stowe. It's a German, started 60 years ago in Germany in the Black Forest. And it's still the same family that started it 60 years ago, the Stoepmeister family. It's now on the third generation of the Stoepmeisters, but still a family-run and family-controlled business from Germany. They're now in over 40 countries across the world, including Canada. And the system that we're talking about that's applied to the Skyrise panels is one that was really, the basis of it was developed right at the beginning of Stowe. They went from their claim to fame back then that really made a mark for the company was when they went from the old cement-based plaster systems to acrylic textured plasters. And shortly after that, they developed an exterior cladding system that included an insulation layer with the new, back then, a new acrylic textured finish. And that was the birth of the RIISE system. You hear people mention RIISE, that's where it comes from. So it was brought to North America about a decade later through a license agreement, but that's been around now for 60 years. And what we've been doing lately is we've been introducing a lot of the new developments that come into that system with new products and new finishes, so that when a company like Skyrise applies a Stowe cladding system to their panels, they're using 60 years of experience in development and innovation that's been invested in those products and those systems. So right now we're combining what we think are the best possible products into a form of manufacturing and construction for exterior cladding systems that deals with, and I won't take your thunder away, but it deals with some of the deficiencies that traditional building has dealt with for decades. It solves a lot of those problems, and maybe John, you can talk about those.
Yeah, off-site construction has always been a term that fascinated me. Coming from the low-rise world, I have experience in the different claddings or veneers that we would typically use in residential construction. But Stowe is one that piqued our interest back in 2015 when Joe and I were looking to offer our clients more people such as Marco, who are looking to be able to add value to their purchasers and give them something a little bit more than what we've become used to in construction. Being the last industry to adopt technology, this is something that was really attractive to us. You know, the formalized program. I don't know if you mentioned, but the formalized program of Stowe Panel in the U.S. and being, really the first affiliate in Canada to be offering Stowe Panel to our clients, such as Marco. But the overall benefits, we talk about that not being limited architecturally. We could talk about eaves or stucco or whatever term you want to use, but these are exterior insulated finish systems, and we're not limited to just acrylic renders. All kinds of products that we can put onto the panel depending on what the designer or client has in mind. The alternatives, if you will, these acrylic renders seem to be the popular ones because you're getting the same look, if not better, with the durability factor that we talk about above and beyond the conventional methods of traditional brick or even stucco. We have these things that we're able to offer in this formalized program, and it's become quite attractive to our clients You know, some of the benefits we talk about, the speed of being able to do things off-site. So, you know, traditionally,
Quality control, you can keep that quality control going on inside the shop.
Well, it doesn't matter, any time of year, you can put those panels up because they're built in a plant, in a controlled environment. And there's nothing that's field applied, everything is, gets installed from the
Yeah.
plant, comes over, gets installed, any time of the year, in the coldest weather. We don't have to worry about covering the building and having
yeah,
bricklayers.
no scaffolding,
Yeah.
hoarding, no staging,
heat,
none of that.
heat, Nothing,
Yeah.
this stuff, we can enclose the building at any time, and we're not hampered by the weather. So that's one of the big pluses, you know, I like.
Durability, I like the durability
Well,
of it.
no, I like it, I
But
like it.
anytime, I mean, Rudy says at any time, that's a very, very big point.
That's a big deal, because sometimes we schedule the start of construction so that we don't go through 2 winters. We go through 1 winter and have the building enclosed by the following winter. And so the timing is very important sometimes when we're using different types of material. With this system, it doesn't really matter. We can install it anytime. But with masonry, the biggest problem, or field applied,
Stucco, yeah.
well, EIFS,
Yeah.
because we can still do a building in metal studs and then put do the EIFS on the outside, on site. So traditionally, a lot of companies have done that. In this situation, we have very few locations where we have some field applied on B-line, but most of it is all manufactured and delivered to the site. And also where it's helping us is if we were to do field applied, we'd have trouble with the power lines. There's very limited space between the power lines and the facade of the building. So we basically have to drop the panels down between the power lines and the building. There isn't room for these.
Not even a baker scaffold you could put in there.
Baker scaffolds or the zoom boom
Yeah.
or those scissor lifts or whatever. There's no room for that. So when you have a tower crane, you just drop the panels in place. I like it because I don't have to have another trade on the inside to build the studs to insulate vapor barrier and drywall. When the panels come to get installed, and all we have to do is insulate, vapor barrier, and drywall. We don't have another trade like a drywall trade having to build a structural stud wall on the inside and we're gonna finish the outside. So it's a lot quicker using the stove panels. We also get a higher R value typically than we have on a conventional, say, precast building. We put the 6-inch studs on the inside, and we have the insulation. But this, along with the panel is 6-inch studs. We fill that void with insulation, but we have the insulation on the outside too, which gives us an R value of what?
It depends. I mean, we start at a minimum of 2 inches.
Yeah.
At a minimum, which is like 3.8 per inch.
So it helps, right?
7.6 for what we're doing
So
there.
we're
But
getting-
we can go up to 6.5.
Yeah.
The
Up
point
to 2
is,
stories in a GPS, which is an R30 outside.
yeah, but the point is with the EIFS panel, you already get more insulation R value on the panel.
Yeah.
And with the
Yeah.
OPC, the
Yeah.
building.
Yeah.
The other advantage to using this stove panel system is we can design a lighter slab edge and foundation for the building because the panels do not weigh as much as doing a conventional brick facade or doing a precast facade. Precast is very heavy, big anchors. We have to design a building to carry all those loads, all the slab edges and everything. With the EIFS panels, the building can be much lighter because the panels don't weigh much. And it's the same thing with bricklayers. Bricklayers, if we were to do bricks on the outside, we'd have to have shelf angles on every floor and casting these shelf angles in place. And it's just much heavier construction. You know, I keep saying that we're coming out of the caveman days because we're not building precast buildings as much anymore or masonry buildings. We can't get bricklayers. Cost of masonry, bricklayers, masonry's gone up substantially, and it's getting the manpower. So when you're building the stuff in an environment, it's a controlled environment, getting any look that you're trying to achieve. You know, a brick, you want a stucco finish, you want a rough finish, smooth finish, you want even a wood look finish. There's so many different variances that we can work with and color palettes that go along with it. it's like matching those bricks. Any brick, you can match any brick, right?
Yeah.
So as far as I'm concerned, I love that system, the Stowe system. I've worked with other competitors, whether you want to keep this in or not. I've worked with the Drive It system.
I almost got
So
you.
the Drive It system, and Drive It was another good material. And then there's another material that comes from Durex or Durbond.
Durabond, yeah.
Durbond. So there's other people that manufacture, and then there's the other one, Durock.
Mhm.
So there's other people that do this stuff. But, after visiting the plant in Black Forest in Germany, I was quite impressed with the materials that they use and the silos and where the material comes from the region. And they use marble, right?
Yes.
They use marble in their
An
rendering,
aggregate, yeah.
in their material as an aggregate. They don't use quartz. So a much nicer finish, I guess. So these are all the things I really like.
It relates to durability. It relates to
Yeah, so-
durability.
yeah.
So talking about the durability, about the areas like Canada, so we know if Stowe is moving into Canada, they've set up, they have a place on Highway 27, I believe. Is that the
Albion
location?
Road is our
Albion,
head
right,
office.
Okay, so their shop is there. The manufacturing of the product is still done all in Germany and then shipped
No,
here,
yeah,
or
also
do they mix it here?
There's several components that go into the cladding system, so each of those components come from different sources. Some of the ones that we're focusing on lately are still imported from Germany, and the Netherlands is another location, as we're developing the domestic manufacturing capability and scaling up here in North America. So Canada's kind of led the way in North America as the incubator for bringing some of the new technologies that have been developed over in Europe by Stowe and bringing them to North America first to Canada. One, because the climate here is similar to what they have in northern Germany and the Netherlands compared to the US, where you have extreme climates in Arizona and southern Florida. So we match more consistently the climate that they've had now in some of these cases with products that have been around for 20 or 30 years, like the EcoShapes, having that kind of experience. There's comfort in bringing it to Canada because it's a similar climate that it will be exposed to here. And it sets us up to establish that product for North America and then scale up for the bigger North American market. But the durability factor that you were talking about is something that over the lifespan of those products, which as I mentioned can go back decades now, they've gone through those cycles of understanding the seasonality, the freeze-thaw cycles, just the mechanical abuse or the physical abuse of being on a ground level in an apartment building. Over the decades, what those products and those exterior claddings are exposed to in the way of just physical abuse, as well as the weather. So
Well, the weather is pretty close to what we have here, and
very similar.
very similar. That's key too, right? So they developed a product in the same type of environment that we have to deal with. And building in the tropics and stuff like that, you don't have the freeze thaw that we have here. There's different conditions, and that's where typically a lot of this stuff was used, right? Stucco material, mainly in the south. We always use bricks and precast and heavy construction.
So to build on that, so what is a Stowe panel? So a Stowe panel takes those materials that were developed in Germany and creates a precision engineered panel that we design in a factory, which is framed and then has multiple layers of materials on it, including the air and moisture barriers, including the insulating properties, and also then puts on those exterior finishes, whatever the customer likes and wants can be done. But it's all done in a factory in a controlled environment, ensuring that the quality is there consistently on every panel to ensure that there's durability in service for that panel. It lasts a really long time. So there's so many factors to it as well.
And we're talking about, like, conventionally, back in the day, not so long ago, there was this tendency to use the heavier products, and there was the mindset that, the heavier the better, and that's changed radically, I think, over the last number of years, where we're looking more to engineers or building scientists that will analyze what the proposed envelope or exterior of a building would be and how that would perform. And we've found and we've proved that weight has nothing to do with it. Because it's a lighter system doesn't mean that you're sacrificing on that performance, whether it be durability, whether we're talking about energy sustainability, when we're dealing with R values and whatnot. And we talk about insulation, but in this case, like stove panel is, we have the CI designation, which stands for continuous insulation. So you're continuously insulated on that envelope, which is allowing less leakage of air, overall a better performing envelope for that building, no matter who the end user is. I think that's an important factor that people need to be aware of.
Well, all the leading building science experts, whether you're in Canada or US market or globally really, they all will come to the conclusion, have come to the conclusion that it's more efficient to insulate a building from the outside with a continuous insulation layer than trying to insulate it in discontinuous segments from the inside of the building. It's like, you're cold in the winter, you put a coat on the outside of your body. It's just a more efficient way to insulate. And you'll hear the term effective R value. And what that means is when you're putting an R20 bat inside studs inside your building, you're not getting an R20 performance, a true R20 performance. And in many cases, the reduction in performance to an actual R value, effective R value, is 50% reduction. When you put that 2, 3, 4, 6.5 inches of insulation on a stove panel by Skyrise on the outside, you're getting that full performance of that R value. There's no reduction because it's continuous and it's on the outside of the building where there's no thermal bridging taking place. So
And you're enhancing what's on the inside. If you are adding the additional traditional bats,
it's over and
that
above.
effective wouldn't go down by 50%. It's going to perform a lot better.
That's right, because you're keeping the studs warm now.
That's right.
Your structural studs are warm, so you're not getting the thermal bridging that you would with
And that all
just the
falls back
interior.
down to being at an indoor environment, factory setting. To find
Yeah,
all
because
this.
even
Hard to do on site.
Even like you're reproducing a brick facade, and when it's completed, you can't tell the difference between real brick and the stove panel. What I like about it is the quality of workmanship. If you look at this panel, and people don't really know it's a stove panel, they look at the workmanship. It looks like amazing brickworks.
Yeah.
You know, and
Yeah.
that day,
Good artwork.
today we don't have that type of workmanship anymore. Masons are not what they used to be. And you know something, when you have, what I found with masonry, you get dilate changes in the materials in the brick, and it's blotchy.
Mhm.
And sometimes when you're working in adverse conditions, sometimes the mortar is a little bit wetter, and they get it on top of the brick surface, and even after you try to wash it down and clean it, you always see some type of film. And
Affluescence, yeah.
it does. Well, it's the masonry stuck into it. It doesn't look uniform and nice.
No.
This looks nice and clean. It looks like
Almost too good.
It can't be never good enough.
Yeah.
Masonry work has to look perfect.
Yeah.
You know, and you know something. It's come a long way. Like I've done different methods. I've done precast panel with real brick slices, and it looked really amazing. But again, heavy panel, concrete precast panel with the embedded
Half-inch veneer.
half-inch veneer slices embedded into the concrete, and like those panels will last forever, but the cost of those panels and the weight.
80 pounds per square foot, yeah.
So those are all
And
things.
not to mention the impact on the environment of concrete, right? That
Yes.
concrete, it's
Number
really
2
bad
CO2
for-
producer.
It's
Yeah.
really bad for emissions, so this
People
helps,
don't know that.
helps improve our environmental footprint, and we've got to do that for sure.
I was impressed with the product when we were out in the Netherlands, is where we were actually grabbed a piece of brick and compared it to a building that was
Remember
standing
that?
for 30 years,
Yeah.
and it was like, it looked
And we use that
exactly
in
the
our
same.
marketing now. People, it's hard to believe. It's very similar, Marco, to why we took our first trip. And it was my first trip as well when we all went together. You didn't end up being the first user, if you will, in Canada, but you were concerned. You said, listen, this looks amazing. What's it going to look like 2 years, 3 years, 10 years, 20 years, 30 years from now? So that's why we took that original first trip.
We definitely like to scrutinize products.
Yeah.
Before applying them onto any of our developments, because we've been around for 35 years, and that means that in the next 35 years, I'm still gonna have to stand behind my products.
Absolutely.
And whatever I do or put into my developments, I need to make sure that I stand behind. So that was the intent of going to Germany twice, to make sure that we scrutinized through it and asked all the questions and saw where it was produced. And I'm quite satisfied with, we definitely have a winner, and the way Rudy put it earlier, says we're evolving from a caveman place. So just because it was heavier and maybe costs more doesn't make it better. In fact, if you look at before the masonry with framed type of construction, you go back to the Mediterranean homes, and if you've ever gone into an old house in January in Europe, it does not feel very good. Your
wet,
bones
it's cold,
feel bad, and
yeah.
so what we found is masonry does not make a house better. Insulation makes a house better. The ventilation and the mechanical systems make a house better, and this is why in North America we focused on building science so strongly to make sure that we brought house comfort, home comfort to the forefront, to make sure that the end user is going to be as comfortable as possible living in their space.
Yeah.
And that's, this product is what does bring that to the forefront, because we have the insulation factor that, and the continuous air barrier that brings that to, brings that opportunity. So combining the Stowe and Skyrise system with our geo-exchange system that we're incorporating into 8 House is going to bring a perfect living environment to the end user. So this is the building science coming together, creating the tomorrow house today.
Yeah.
And that's what we're doing here with always searching for new products to incorporate. But we just don't take them and throw them in. We make sure we scrutinize them, because we know we have to stand behind them.
Absolutely. Yeah.
And Marco, you mentioned the homeowner being conscientious of the performance of their home. The reason we came up with the name for the product, EcoShapes, that's the replacement of the traditional masonry brick. It's because that product, even though it was developed many years ago in Europe, it has a much lower carbon footprint than a traditional masonry product. It's cured at 60 degrees Celsius, whereas a brick would be cured and fired at 1,000 degrees Celsius or more.
Using so much energy.
And the carbon footprint in the manufacturing
shipping.
is a lot lower. In shipping, you get 15 times the amount of square footage, wall square footage in a truckload of EcoShapes compared to a truckload of traditional brick. So, that's where the name, that's the eco in the name EcoShape. It's an important factor for us, because Stowe, one of the embedded cultural elements of the company is this building with conscience that you see now in our branding. Having products that have low carbon footprint, are sustainable and ecological, is very important. So, you're taking good building science and a very environmentally friendly product and combining the two into a very effective system.
Well, at 8 House, the Stowe product is just one component of building a better environment with a less carbon footprint for our homeowners. What's nice about 8 House is, like Marco was saying earlier, the geo-exchange. The geo-exchange helps lower the carbon footprint also, because it uses the core of the earth
Ground source, yeah.
to heat and cool the water to whatever we need, whether we need heat or we need cooling. So all of a sudden, we've eliminated the use of big chillers and cooling towers and all this stuff that you would normally have in a conventional condo. Or if you were going into individual units, for each unit, every one of them would have to have a gas line, and it would be burning gas to give you heat. Here with this single source, we have one gas line going into a single source, And that single source will be providing heating and cooling for the whole building, along with a generator that will give us power to power the whole building, because we don't have any of these big components that take up a lot of electricity. So this generator would be able to power the whole building because of the geo exchange. And doing that, we can also operate the generator using less energy than it would take operating the building, taking the energy from the grid. It would produce the power at a much lower cost. So for us,
Plus you're heating the underground, are you not?
Yeah.
the what do you call it? The excess heat from that's generated from the geo exchange, we can heat the whole underground garage just with the excess heat that's produced
Sidewalks.
from sidewalks,
Snow melt,
ramps,
yeah. Nice.
all the snow melt. This is just the excess the excess energy that we pull from the ground.
But we're never taking away from the ground. We're actually, that's why geo exchange, we're putting
Putting
it
it
back
back,
to
too.
what we don't use.
If
So
you've
it's
seen, if you've
always,
seen in buildings where you go around downtown, you see the bottom where the salt's been exposed to the masonry and it starts
Chewing away,
eroding.
yeah.
So in this building, though we're not using masonry, and I believe that the stove product even will withstand salt better than a masonry product, there will be no salt around the building.
Because
So
it's
the
all
stove
melted.
panel will actually not be
Exposed.
exposed to anything, because the ice melting will eliminate any requirement for salt around the building.
Yeah.
So that's even an additional bonus to the durability of the home.
Bonus to the homeowners and
well,
their
it means
shoes.
less maintenance,
I
right?
mean,
Less maintenance,
salt,
less
think
maintenance
about it
costs.
if you think.
Well,
about it.
there's other things that
And their
Marco,
cars.
Or the cars.
there's other things that Marco's designed into this building, is to try to build in an effort to have less garage space, has put also car stackers. So you have a parking space, instead of having one parking space, you've got two because of a car stacker. So we've implemented those things. Also, on top of that, we've implemented EV chargers, because it's a big thing in the next 10 years, electric powered cars. And more and more, every year, there's gonna be more and more electric cars out there, and reducing the carbon footprint by not using cars that have combustion engines. So there's a lot of things going into this building that I'm sure we have other things that we could talk about, but the basic ones right now are the stove panels, creating less of a footprint, better R values, the geo exchange, using the energy from the earth, using less natural gas, building less garage, concrete, less garage, going deeper, building more parking spaces, using car stackers, using the EV chargers to try to, accommodate a lot of people buying electric cars. So all these things going into one building, I think it's cutting edge for us.
Absolutely.
Now, the CFS system itself, this is not a European system.
No.
So maybe you can elaborate on the CFS system and how it works and where the materials come from.
So CFS, cold form steel, the shiny studs that we're typically used to seeing in more of an industrial or a commercial application like the business park that we're in here, dates back to early 50s, I think, when they were actually using it. But to use it formally in a panel system, even prior to Skyrise, Joe's in his former life working with KML, panelizing and working with Rudy, even way back when, doing a number of units in panelized cold form steel walls. We talk about carbon footprint. Here's a product that is 85% post-consumer scrap. So refrigerators, cars, you name it, whatever it is that we're recycling. Locally sourced, DeFasco out of Hamilton. It's all ArcelorMittal now. He owns all of these steel mills and whatnot, but it is locally sourced.
So it's all domestic product.
It's all domestic product. It's not coming from overseas or anything like that. But that's how we started. We were primarily a structural offering. Our clients actually, similar to yourself, were continually driving us more and more to offer them more on the exterior. We do have some competition there for us, when we started researching, you know, what sort of offerings were out there, we quickly grabbed a hold of Stowe and started that relationship back in 2015, becoming the first affiliate in Canada to actually start installing Stowe panels. But for us, it was an easy decision. It was an easy decision. We talk about, you know, the offer. I don't know what we're up to, like 800 and something products now available globally. So we're not limited in that respect, and that's a big thing for us. We don't want to get up from our client's table saying, "I'm sorry, we can't give you that. I know that's what your architect's looking for." You know, we're
I
not
think just
limited.
being with Stowe itself, so Skyrise being a company that has not been around as long as Stowe, being there and being part of it
Lends
also
a lot of
brings
credibility, yeah.
it brings the comfort to a developer and then the end user that we know this is a product that is not here today and gone tomorrow. This is a product that's going to be here today and just continue to evolve with the industry in years to come.
Yep.
Stowe is not a player that comes in and disappears. They're a long-term player that has been in construction probably longer than most companies in construction out there today. So that also, when I saw that combination between Skyrise and Stowe happen, it definitely added a lot of comfort from my end as a developer. And when as a developer I feel comfort, I know that the end user and the buyers also would feel comfort in that.
Yeah.
We've also invested a lot in the manufacturing of the Stowe panel. We've had Porsche Consulting in. They are looking through all of our processes to make sure that there's consistency in place. We have the right quality checks, and so that the product that's delivered to the consumer and to the end user is up to the standards required for it to last for a very long time, and it will retain its look and ensure that it's consistent. Every panel is the same.
But you know, on the heels of what Mark was asking for CFS, like, I mean, if you're looking at low-rise construction, you're comparing it to wood, there are so many benefits. But even on a mid-rise application such as 8-house, we're using 30 to 40% less concrete than conventional methods. And again, that relates back to you know, CO2 emissions and the imprint that we're leaving. You know, again, back to that mindset, we've gone away from wanting to leave a big footprint to having a minimal impact on our society and becoming more educated with respect to, you know, what we've done and the effects of our methods of past and how they, you know, impact on the world. These are all things that lend themselves to lessening that footprint, being more ecologically, you know, mindful, if you will.
Well, on
you
the
know,
heels of that, our Stowe panels weigh about 8 pounds per square foot, where a precast concrete wall
Is
weighs
80.
80 pounds
Yeah.
per square foot. It's a big
Yeah.
difference.
Oh yeah, it's huge. I mean, we don't have to get into names, but we did a local project study here with yourselves, where the undergrounds, first off, they had to take the underground out of the original design for poor soils conditions. When we came on board and proposed our system, we came in just a little bit higher than 32% or so lighter overall for the building, which allowed them to throw the underground back without too much extra work. But the neat thing there was, because our building was so much lighter, the savings on the underground for reinforcing steel, column and cap sizes, the number of columns even was reduced, foundation wall thicknesses, footing size and thicknesses, they're just shy of $2 million savings to the developer, which is huge. And that, of course, will translate to the end user. I mean, everybody wants to be competitive. Budgets drive everything, and you know, you've got your normal markups, if you will, or profits you want to take on each project. You're able to offer those you know, superior units at an even more competitive price. So everybody wins. I mean, it's a win-win-win proposition all around.
And the nice thing about it, none of these products, none of these systems are just developed now. They're
No.
not new. They've been around for over 20 years.
That's a really important.
That's important. So we're not trying something out and then, you know, being the guinea pig type of, if you will, right? So
And that includes the panel concept, the prefabricated panel concept, even though Skyrise has only been around for a few years, and building and installing the Stowe panel design. They're drawing from many years of experience and a network of Stowe panel affiliates throughout North America This really started in the US with a panel affiliate, Stow Panel Affiliate Network. And now there's well over 30 independent Stow Panel affiliates throughout North America that are all sharing ideas and best practices and design. So you've got well over 2 decades of panelized and prefab finished panel experience that is being shared with a company like Skyrise. So when they're producing here in Southern Ontario, you're getting the benefit of all that experience. So it's not a new concept.
There's a lot of power behind, you know, that affiliation, if you will, and Stowe stands behind it.
Yeah.
I
Now,
mean,
what's
we-
the difference in weight between the CFS panel compared to a precast panel?
80 pounds.
1/10. So a precast is
1/10.
80 pounds per square
So-
foot.
so
A brick veneered
Would I be
wall.
able to say that because the precast panel, basically their size is controlled by the weight the crane can pick up? And so you could say that you could get a CFS panel that's 10 times the size of a precast panel, pick it up with the crane, which would make you move along 10 times as fast when you're putting up these panels
Well, the
compared to
size of
precast.
the panels are
You're
a bit
covering
bigger.
more area.
They're a bit
so
bigger, yeah.
You're covering more area, you're getting a panel much bigger, so you can stack those up against each other, so the speed
There's
would
less
be
joints.
a lot faster.
Less joints as well.
Less joints.
Yeah.
It's a big thing, right?
Yeah, so you're mitigating risk there.
Yeah.
Yeah, our average panel size is, again, depending on the complexity of the building and the overall
Yeah.
elevation, how many turns and whatnot you have. But I think on RIISE, we're averaging well over 200 square feet per panel. That's a big deal.
Yeah.
We do even 3-story panels. We're doing projects right now where we're doing 3-story panels. Some of the affiliates are doing 4-story panels.
Well, it brings the
We've all-
cost down, the bigger the panel they put up,
Yeah.
or even making the panel.
Well, it goes back again to caveman days
Yeah.
where, why pick up something so heavy that's smaller and it
Yeah.
takes you more time when you can pick up something much bigger, which is lighter, and it has a better R value, and you can go faster. So it's just kind of, it's just showing you, construction science is making us evolve to a better place.
Yeah.
Well, to give an idea on RIISE, like some of our precast walls that we installed in the core for
On
over a
Beeline?
12-foot span.
Beeline.
Sorry,
Beeline.
Beeline. Over a 12-foot span, those would be weighing somewhere around 16,000 pounds for a precast panel, precast wall, where a load-bearing CFS wall can be maneuvered by 2 or 3 of our construction installers.
Yeah.
Maneuvered into place by hand. Don't need a crane.
It's like we talk about housekeeping and general site conditions. You know, we have crews of 5 or 6 guys installing these wall panels versus, I don't know, how many, 30,
Yeah.
40 drywallers that would be doing
Yeah.
traditional stick framing. So that's a big thing too, especially if it's a tight site. You know, zoning bylaws are being more and more relaxed, if you will. Our building envelopes are encroaching closer and closer to those exterior lot lines. We're talking about the challenges about accessibility and whatnot. All of these things lend themselves well to the, you know, off-site or prefabricated offer. Yeah, so that there's a lot of benefit there.
And with the demand for housing in Ontario, you know, this system allows us to get at more buildings because there's such a shortage of the trades, which Rudy had mentioned before. There's a lack of trades. There's demand for housing, but it can't be built without the trades and the traditional methods, and that's why the Stowe panel and the prefabricated Stowe panel is the new construction method, where we can get the buildings up to satisfy the needs in the community.
Yeah, that's a good big one, labor shortages,
Well,
absolutely.
the cost, even the cost of precast is huge. And the thing is this, if we were to use precast, like I said earlier, we gotta build stud walls on the inside. The panel comes with the stud wall on the inside already. So on top of the cost of the precast, we still have to build those walls. So there's a big cost saving there, cost savings between precast and the EIFS panel. Precast is very, very heavy construction. And, you know, once the precast all goes up, you know, besides of the cost, there's some serious welding to go on, like there's serious welding to hold these panels in place. And the cast in place plates that have to go on the concrete, there's so much anchorage to hold up that heavy panel. and they're not very big. You can't make the panels over a certain weight because of the loads the crane can pick up. Like at Beeline, we have the core of the building is precast, and some of those panels are pretty heavy too. But again, those panels were designed, we need those panels for the core of the building, for the elevator shaft, and we could do them in block, but it would take forever. Doing them in precast, they install them very quickly. So between the stairwells and the elevator shaft, those panels are also, they're designed for the crane to be able to pick them up. So they go up very quickly when they come to do the panels for the particular floor that they're doing. So that's just something we have to live with, because the core has to be done in some type of either masonry or poured in place, cast in place concrete, or precast panels. So I like the precast panels.
And that's even changing too. I mean, we're looking at a building right now, and we can certainly look at it for 8 house.
Do it in a different
So,
way,
yeah.
studs and drywall.
Yeah.
Upgrade the fire rating.
Mhm.
Yeah.
There's a form-in-place CFS wall system that we're looking at now with one of our suppliers that would allow us to monolithically pour shaft and stairwell walls with your condeck.
Oh, I see.
Yeah.
Like a form type idea.
Yeah, like a sandwich, if you will.
What's that stuff called?
Which,
The stuff there, those plastic separated.
oh, the insulated block,
ICF?
the
No.
ICF block.
This is actually a CFS preformed, stay in place.
You
So
just fill it with
you
concrete.
just fill it with concrete. It comes tied together with the rebar and everything. You just have to tie it in with your floor system, and then you can do a monolithic pour.
Okay, so the other walls are still precast, look.
No.
Nope, CFS.
CFS.
CFS, but you have the fire rating. You have the fire rating, yeah,
And you pour that, when you pour the deck, you pour the wall
Yeah.
at the same time.
yeah,
Yeah.
yeah.
So now the CFS system compared to the traditional concrete, or then now you have even wood is going up to 6 stories. Seismic resistance testing, you guys.
So nothing outperforms. I mean, even on our website, we have it in the video sections in our resources. A study that was done by Berkeley out in San Francisco campus, where they have the world's largest shape table. Pardon me, I'm not sure that was in San Francisco. They compared it to the largest earthquake ever in North America, which was in San Francisco in the 1800s, and then kicked it up one more on the Richter scale. So they tested it to 9 point something on a 6-story structure. The wood went once, and then the second time it just fell over that way. Where it first started the motion,
Yeah.
when it changed the direction, it literally it didn't even make it past one wiggle. Concrete didn't make it past a few. The CFS structure was continuously shaken. Very, very minimal drywall damage inside. Then they tried to burn it, and they couldn't do that either, and they ended up having to dismantle it. And that's all in the video. But from that standpoint, seismic, for regions like Ottawa and St. Catharines, both of which we worked in, there's nothing that outperforms CFS. Absolutely nothing that's available right now. That's a good point. It's one that we don't talk much about, but it's definitely something that depending on the region, it's
The
important.
worst case scenario where you've got your cold formed steel panels on the outside rather than precast would flake off and break down and land on the roads below, where
Because of its
this
weight.
would probably stay on the structure.
Yeah, because of its weight, makes it very susceptible to causing a lot of collateral damage.
Going back to, we're just evolving to a better place and not caveman days, it's progress. This is a progressive type of product that is only bringing us benefits and no drawbacks. And that's I think, where we've all seen that landing point here is with the Skyrise stow system. Through all our research, our trips, and scrutinizing the product, we've seen just pure benefits on moving forward with
Yeah.
this kind of a system.
Yeah,
Well, I think with all the systems that we're using for 8 House, all it does is gonna lead to a better product for the end user. And,
Absolutely.
That's what's important, and
Top
less
notch,
maintenance and,
top notch, yeah.
costs and-
yeah.
Construction's going through a revolution, much like the computers went through in the 90s, where they changed so much every time a computer came out. It just leaps and bounds and changes in technology, and that's what's happening with construction, with prefabrication. It's the application of all of that knowledge that everyone has gained over the years, combined with the technology and the products that we have available to us, to take it to the next level, to be more precise, not to be so rough and tumble in how we build,
Exactly.
but to be precise and to deliver a better product to the customer.
Yeah.
For sure.
Are you using any Lotus on the 8 house?
So we only use Lotus On. It's not even something that we offer to our clients as an
So
extra.
it is on that project.
The Lotus On, wherever it's available, we use Lotus On. Which, and he's talking about the property that
The weather
is
array.
included.
So the,
Well, it allows for the washing
Yeah,
of
that's
the
my
wall.
favorite part
so
about
the
it.
parts of that building that are acrylic stucco
Yeah.
finish,
Yeah.
it's, Skyrise is utilizing a still product called Lotus On. And it's a biomimicry product where they've taken the lotus leaf and they've analyzed at a microscopic level.
I
what-
remember you guys talked about
You
this.
saw that in Germany,
Yes,
right?
yes.
And how water beads off the lotus leaf, and it never really comes in full contact with the leaf, it stays on the
Yes.
surface. And any dirt or debris that's there gets washed off by the water beating off. So
So
this,
like a car wax. that
It's
kind
like
of-
Rain-X for your windshield.
It's my favorite part of it, because you see a lot of these beautiful buildings when they go up, but then after a couple of
6
years,
months
the
even.
environment, acid rain, it starts changing
Road
color.
grind,
Staining,
road
Road
grind.
grind,
Staining,
everything,
yeah.
staining, water staining. With this Lotus On product that's on to be on the building, it just washes off.
Yeah.
So the building, the way it's finished, it's gonna be like that years down the road.
exactly, people refer to it as a self-cleaning building,
Yes.
because every time it rains, it just cleans
It
off.
washes it off.
Yeah, it's like on cars now, they have this ceramic coating.
Yeah.
Yeah.
It's the same type of
It's
idea,
similar.
that ceramic coating the car, like nothing sticks to it.
No.
Yeah.
You know what I mean?
Yeah.
So, no, it's a really cool thing that they came up
Yeah.
with,
Yeah, that's good.